Today we're going to do what is called finding the zero of a function. In other words, we're going to set a function to 0 and find its y-intercept. Okay, let's look at this lesson opener. Let's remember back when we were trying to find y-intercepts, we simply changed the x to 0. So for the first one, if we change the x to 0, then y equals 7. For the second one, if we change the x to 0, y equals -9. And for the third one, if we change the x to 0, then y equals 5. Now let's look what happens whenever we solve for x when y is 0. If you'll remember, one of the ways we found our x and y intercepts was to change x to 0 and find the y, and then to change y to 0 and find the x. So in the first one, when we change y to 0, we're saying 2x squared minus 8 equals 0. We need to actually solve that out, and we're going to end up with x equals plus or minus 2. On this next one, whenever we actually solve it out equal to 0, we're going to end up with x equals 4. Now let's look at how we specifically find the y-intercept of a function. So your y-intercept can always be found whenever you have an x value of 0. So whenever we have a function, we're going to put 0 in for our x's, and that'll give us our y value. So if we look at this function, if we think of it as having a 0 in the place of the x's, then we end up with just 5 because we have 2 times 0, 3 times 0. Our answer is 5. So our y-intercept for this particular problem is 0, 5. Let's look at this one. If we put a 0 in for our x, we have x minus 1, or we have 0 minus 1, which is -1, squared is 1, plus 2 is 3, so our y-intercept is going to be 0, 3. Now let's look at what it means whenever we talk about zeros of a function. When we look at the x-intercepts of a graph, they always have the y values of 0. So your x-intercept intercepts the x-axis, which means your y value is 0, and vice versa. So whenever we make y be 0, we can solve for x, or the function of x can be 0, however it's written. So the 0 of your function is where the function crosses the x-axis, the x0 spot. So let's look at this example. This example is actually in 2 parts. We have 2 different problems to solve on this one. So we want to find the zeros of r of x equals x squared minus 4x minus 5. So if we want to find the x value, the x-intercept, we're going to change our y to 0. So that means that we're going to change our x to 0. Here. That changes, this is the same as y, and we're going to change that to 0. So then we're going to just solve. And we end up, once we factor out this problem, we end up with x minus 5, x plus 1. So our x value is either positive 5 or -1, which means our x-intercept is either 0, 5 or 0, -1. Now this next one is pretty similar, except we have this negative sign in the front. And we don't like the negative sign to be in the front of a quadratic function. So we're going to actually factor that out by factoring out a -1. And then we, of course, set it all to 0. And whenever we factor that out, we end up with obviously -1 doesn't equal 0. X minus 2 equals 0. Whenever you solve that, then x equals 2. Both answers are the same, so you can stick with one answer. Okay, so whenever we saw that second example, it's sometimes called a double root because both factors factor out to equal the same thing. They both equaled 2 in the end. And whenever this happens, the parabola's vertex is going to be at the x-intercept. So that's a little hint. If you have something, one specific function squared instead of two sets of parentheses, then you're going to end up with your vertex at that spot. Okay, let's find the zeros of this particular function. We're going to change our y to 0, so then we have x minus 1 quantity squared minus 6. When you solve it out, again, we have a double root because x minus 1 happens twice. And we end up with plus or minus 6. Now, in this particular example, our instructions were to find it to the nearest hundredth. So we're going to put in our calculator x plus square root of 6 or 1 plus square root of 6 and 1 minus square root of 6. And we'll find both of those answers and round them as the instructions say. Now let's look at this one. This one you may want to use the quadratic equation for, because we have a 1 here and there is not anything that factors to create 1 out of 4. We have 1 and 4 or 2 and 2. So it's going to be very hard to factor this. So let's put it into the quadratic equation. Once we figure it all up, we end up with this. Now we have a negative inside our radical. That's not possible, right? So that means there are no real zeros in this particular problem. Okay, let's do one more example. Okay, we have 3x squared plus 8x minus 3. So we can go ahead and our instructions are to find the y-intercept, the zeros, and the vertex. Now before we've been finding the x-intercept. When we find the y-intercept, we have to change our x's to 0. So we're going to change all of our x's to 0. And we end up with -3. So our y-intercept for this is going to be 0, -3. And we also need to figure out the zeros. Our zeros are going to be found by setting this equal to 0. So we're actually going to change our y to 0 this time. And we're going to factor that out, and we have 3x minus 1 equals 0, or x plus 3 equals 0. And when those are solved out, we end up with 1/3 or -3. So those are our two zeros. And then the last thing we're supposed to do is find the vertex. Our vertex is going to be either at 1/3 or -3. Let's think about this a little bit and let's look through it. So whenever you're looking at the vertex, we find our h. So in our original formula, we had h's and k's. If we find our h, whenever we're looking at our A, B, C, H is found by doing b over 2a, negative b over 2a, and that would be, our b is 8, 2, and our 1 is 6, or is 3, so that equals 6. So this is 8 over 6, and there's a negative in front of that. So that equals out to be 1 1/3, and this is going to be our vertex, our H part of our vertex. Our K is going to be, we're going to find the function of that. This is the same as 1 1/3. We just put it into one improper fraction, so it's easier to deal with. When you put this in for all of the x's, then you end up with 8 1/3, or negative 25 over 3. So therefore, our vertex is going to be at negative 4/3 and negative 25 over 3. And then the last step in our instructions for this is to actually graph this problem, but you guys know how to do that, so we're not going to go over that. Go ahead and get started on your homework. It's 1 through 35 odd.